Okay, let us see graphs of functions. Now last time we considered real number system and we have taken functions for that. Now we use boxes to represent sets and to show functions, but actually boxes won't be a proper method for us to actually see functions, because if you are drawing an area, it means the function, the domain is confined to that. But if you see real number system, you represent it by a straight line, by real number line, because real numbers are infinite and you don't have a fixed number of real numbers. So instead of that, we will take a graph. You know Cartesian system, right? Y-axis, x-axis. We'll take y along y-axis and x along x-axis. For example, if I consider y equal to x square function, okay, it is orthogonal 90 degrees. I need to mention scale. If I take y equal to x square function, what is 1 square? 1. 2 square? 4. So something like this it goes. As x increases, the x square becomes even bigger. And minus 1 square? 1. Minus 2 square? 4. So it's something like this. So if you see, this is like a mirror and it is its mirror image. Like if you draw it on a paper, if you cut this out, you fold it, will exactly be congruent like this. Why? Because of neat symmetry. F of minus x equal to f of x. So if you see, if you consider a graph, you are getting lots of information. A picture is worth 1000 pages of data. That's why we prefer graphs to actually study functions. Now there are different types of functions and you can see them better with graphs. Now is this, what is the condition that it should be on to? If domain is R, when will it be on to? If the codomain is R plus as well as 0. So you can see the range. This is the range. That is along y-axis, which all points are there. This point is there, this point is there. So all these numbers are the range. So that is set of real numbers minus negative numbers is the range. Now what is domain? All the things where it is there. Now a simple question for you. This is y, this is x. Is this a function? Is this a function? Answer is no. Why? Just draw a line parallel to y-axis. You will see for this value of x, you have got 3 values of y. So f of x has got 3 values. So it's not a function, it's a relation. Okay? So this is not a function. So if you want to test whether it's a function or not, just draw a vertical line, that is line along y-axis, and check whether it is intersecting at one point or not. And it should intersect at one point. If it doesn't intersect anywhere, that point should be remained from domain, or else it will not be a function. For example, take 1 by x. If you plot 1 by x, it comes something like this. Now put x equal to 0. At x equal to 0, if you draw a line, it will not touch the function. So it means that x equal to 0 should be remained from domain, should be removed from the domain, or else it will not be a function. Okay, so if you want to take y equal to 1 by x as a function, x equal to 0 should be removed from it. So that's why when ax equal to bx, if you want to apply the function 1 by x on both sides, x equal to 0 if you are applying, that's why you are getting a equal to b when x is 0. That is the error. Because you are supposed to apply a function, but you are not applying a function. Because at x equal to 0, it's not defined, it's not a function. Okay, so if 1 by x has to be a function, x equal to 0 should be removed from it. Now how to see if it is 1, 1 or not? Just draw a line like this, parallel to x-axis. See how many points it will intersect. It is intersecting in 2 points. So 2 values of x are giving same value of y. So it's not 1, 1. Take y equal to x plus 2. It will be a straight line. Draw a line perpendicular to x-axis. It's going to meet only in one point. So it is 1, 1, 1, 1. If it is on, is it on to? Yes. Because range is R and codomain is R. It is understood that it maps from R to R. Generally when they give you a function, it is understood that they map it from R to R.